All right, we're going to be talking about the life cycle of a star today, which is all about fusion, which we've talked about. To fit the theme of our video, I have my solar system mug here with me, handy. But let's jump into stars. So, stars, you've seen them all before. Here's a whole bunch of constellations that you might know of if you've ever taken like an astronomy class or watched like YouTube videos on astronomy. We have lots of constellations. We have lots of stars. Sometimes they are hard to see them all really if you're in a light polluted area, but if you go to somewhere more secluded, you can see the whole Milky Way, which is pretty cool. What we can't see from Earth is all the different types of stars specifically. They all kind of look the same from where we are. But we have things like red giants, red supergiants, blue giants, white dwarfs, red dwarfs. So we have all these different types of stars, and they all fall kind of in different times of a star's life cycle. All right, so we're going to talk more specifically about our sun for the most of this video. So if I'm ever referring to a star, you can kind of assume, okay, our sun, because our sun is a star. And we always think about stars as being a lot smaller, right? From down here, they look like specks, they look tiny, but stars are actually pretty huge. So here's our sun in comparison to all of our planets. So we're right here, we're a tiny little speck, and our sun is just so much bigger than we are. All right, and then just for kicks, here's Pluto. So tiny. So stars can be huge. All right, and then on top of that, our sun is pretty big, but it is nowhere near the biggest type of star it could be. So here's just a little video comparison. I'm going to skip ahead. You can see here's Earth, here's where we are, and then here's another planet. Here's Neptune. So Neptune already much bigger than Earth, and then Saturn even bigger than that, and then Jupiter right here even bigger than that. But you immediately jump to now stars. So here's our sun, right? Way bigger than all those planets combined. Here's another type of star, which is, you can see, a little bit bigger than the sun. Here's an orange giant. And then here is a red giant. So our sun is this little speck down here. So you can see these stars get like infinitely bigger. They get so much larger than our sun is. And I'm going to stop this video here. You are more than welcome to go to my slides and to watch this for yourself. But stars have a huge range in size, and our sun is for sure not the biggest. So just to kind of give you an example about our sun relative size comparison in space. But we're going to dive into the actual life cycle of a star now. So stage one, we're going to talk about 4 stages, the 4 that I want you to know in class pretty well. So stage 1, we have hydrogen fusing together to become helium. So I have 2 hydrogen atoms. They're going to go through that nuclear fusion process and combine, right? Their nuclei are going to combine, and they're going to get heavier. They're going to become helium, right? Which is still a pretty small element overall, but there's lots and lots of hydrogen atoms in the sun, so it's going to take a long time for them all to fuse and for them all to become helium. So as it converts more, the core of our sun shrinks, which causes the outer layers to move closer to the center. So we have the stronger pull, we have a stronger gravitational force in the core. All right, which places more pressure on the core, right? You have more gravity pushing in on it, so you're increasing the pressure of this core. But the sun is going to continue to fuse this hydrogen until it runs out, and the fusion process is just going to speed up and speed up as it goes on. This is currently where our sun is at. So our sun is fusing hydrogen to make helium. It'll do that for a few billion years. So we have a while before our sun moves on in its life cycle. All right, but this is where we're at. So hydrogen fusing to become helium. Our second stage, all right, this would be called a red giant. So this is where our sun will move next. In a red giant, the hydrogen, it's all gone now. So all of the hydrogen has fused to become helium, which means now my helium is going to start fusing to get heavier and heavier. So the hydrogen is exhausted in the core. The helium that is built up there will become unstable. And the core is going to collapse under its own weight, which makes it heat up and get denser. But the outer layer of our sun is just going to keep growing. So it's super hot there, right? You have this intense heat, which means your helium ignites. And so now your heliums can start fusing to become bigger elements. So the example I have here is 3 heliums can fuse to become carbon, right? So let's say you have atomic number 2, atomic number 2, and atomic number 2. Well, if I add 3 2s together, I'm going to get atomic number 6, which is carbon. So the helium is starting to fuse now, right? It's getting heavier. So it's calculated that if the sun expands when it becomes a red giant, right, like I said, those outer layers are going to grow, that it's going to consume Mercury, Venus, and probably Earth. So when the red giant comes, which is billions of years from now, Earth is probably kind of done for. But, you know, we have a while before that. But that is stage 2. So you have helium fusing to become these heavier elements, and we call that a red giant. Our third stage, still kind of in that red giant stage, but fusion is occurring still until we form iron. So you have helium fusing to become bigger elements, then you have those heavier elements fusing to become even heavier elements until it hits iron. So once we've made iron, it gets too heavy. The core can no longer support that kind of weight. So you can see I kind of listed out right here some examples of what this might look like. So now my carbon maybe fuses with a helium, then I get my oxygen. Carbon maybe fuses with 2 heliums, and now I get neon. But once it gets to iron, the iron can't burn, it's too heavy, so the core will collapse again. All right, it can't support that weight. And what happens when the core collapses? Stage 4, that's a supernova. So this is the end of the star's life cycle. Our sun is not necessarily large enough to go through a supernova, and we will look at that on the next slide a little bit, but massive stars, so if you kind of think back to that comparison video that I showed on here, those massive stars will collapse upon themselves and go through this thing called a supernova. So for a supernova, that's when the star explodes. It's brighter than about 4 billion suns, so there's a huge amount of energy that is released when it collapses. The intense heat and energy fuses iron and the other elements. This is where we make all the other elements up until uranium. So you have all these elements in space. This is where all the elements on our Earth came from, they believe. The sun will shed its outer layers then and become a planetary nebula, which will over time cool down and settle down to become a white dwarf, which is a much less bright old star. So eventually it will cool down. It just takes a very long time to do that. Our sun won't go through the supernova stage. It is pretty rare, so our sun's not big enough. So when it makes that iron, it'll slowly start to collapse upon itself and cool down and go through this planetary nebula and white dwarf stage. It just won't have this giant supernova collapse. All right, and to kind of show you what that would look like, I have a picture right here of what I mean what that supernova is. So the star is being held together by the heat and the pressure pushing outwards and the gravity pushing inwards. So when a star runs out of fuel, the pressure drops, meaning gravity can kind of crash it in, and that's what causes that core to collapse. Our sun just doesn't have the mass to go through this whole process, but it'll still cool down, still become that white dwarf. But that's what the supernova is. That's what happens to these massive stars. So for the sake of class, I want you to know what a supernova is. All right, even though our sun specifically will probably not go through this process. All right, I don't want to go any farther. Those are the 4 main stages of a star's life cycle that I want you to know when we're talking in class. We will hit on a couple other things, kind of the in-between stages a little bit, but these are the 4 big ones. All right, we're going to be drawing them out and looking at them a little bit more specifically, but that is the life cycle of a star in a nutshell.